Oh crap. Okay, so yeah, I tried to explain what was going on with this game, but yeah, the thing wasn't on. I was streaming to myself. So yeah, the game's called Noita. It's a physics-based game here, so every pixel in this game is simulated and there's all sorts of stuff going on. I don't know if anyone's played this game or if it's just me. So yeah, I got everything going here. We're gonna do some video gaming live streaming. I think the reason why I want to play some games is I'm working on some longer projects and I want to take a little break from slavishly putting together 3D printers for you guys. But I'll definitely be getting back to that in a couple weeks after tax season and all that. So hello everyone. Yeah, this game's pretty fun if you want to pick it up. It's on Steam. It's called Noita, spelled like this. Secromancer. Prusa sucks with their 75% printed parts. Alright, so someone's trying to start some 3D printer shit in the chat. Good to hear. Jean-Michael Dutil, sup. Good day to all from Montreal. That's a very Frenchy sounding name, so the Montreal connection makes sense there. Okay, so I'm just gonna get going with this game. Basically, you build these wands and attach spells to them, and you create all sorts of stuff. So this one's like a good just damage wand that I can kill stuff with. Then I've got this one that has homing rocks, which is always fun. Yeah, homing rocks, good stuff there. So I'm gonna go get some stuff. If you want to talk about 3D printers, I'm all here for it. But I'm just doing something to take my mind off of all the 3D printer content that I've got in the works. So yeah, I'm like halfway through this run. So it's kind of not going to make a whole lot of sense since I'm not starting from the beginning, since my stream wasn't going when I thought it was. But yeah, I'm a wizard. Oh man. And I'm trying to kill all this stuff. And my favorite weapon is these homing rocks. They do like an insane amount of damage. Because this game's physics-based and these rocks are flying around and they're massive. And they just like walk onto things and collide with them. It's kind of like a hack to do tons of damage in this game. So Yo-Yo Man, hey Bhutan. I don't know if anyone's actually played this game, it's kind of niche. We've got some other stuff too. If you've got recommendations, drop them in the chat. I mean, Minecraft is pretty good. I feel like a lot of people that are into 3D printing might also know of Minecraft. But I don't have the game. I actually would have to repurchase it because Microsoft bought the game. And then they like cut off everyone's old logins and stuff. So. Classic Microsoft behavior. I'm gonna see if I can. This is gonna be a bad idea, but I'm gonna see if I can beat this boss. testing, 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 testing. Can you hear me now? Michel. I can turn down the game too, I guess. Let me turn the game down. There we go. Okay. How's that? I think, okay, thank you for the recommendation there. But yeah, so making YouTube videos takes forever, so I'm just wanting to do something a little lower effort right now. So here's your low effort video game stream. Is everyone having fun doing their taxes? Oh, jeez. Didn't realize that guy was alive there. This might be able to kill that boss that I'm about to go over to, so let's give this one a try. Oop. Whoa. Hello, Herzelnerk. Welcome. Today we're playing a video game. Someone needs to make a 3D printer video game so I can entertain you guys with that. So yeah, for those of you who weren't in for the start of the stream, we're not doing anything with 3D printers right now. That might be disappointing to many of you, but you're just gonna have to deal with it for now. We'll get back to the 3D printer content soon. Okay, so... Oh, jeez. Okay. Oh man, that's a lot of people over there. kind of hard to tell what's going on in this game. Alright, I'm gonna skip past that boss. I'm pretty sure I'll die if I attempt it. There's one, but basically a print farm manager, but a bad one. 3D printing game. I think it'd be fun to have a game where you export what you build in the game into a printable model. Okay, so there's this boss here that I'm pretty sure is gonna destroy me, but I think I should try it. So I carved a hole into this egg, and when I step in here, it'll spawn. Alright, I think I've got this. I got this, maybe. Oh. It basically will insta-kill me if it touches me, so that's the challenge here. Oh, jeez. There we go. I got it. Okay, so it dropped this. I think I'll try it out. So yeah, basically the currency in this game is wands. So you gotta get these wands and go and kill more stuff with it. Okay, and then it's got this really complex system to build up your wands to do stuff, so let's give that a try. And then there's these perks that you can pick up from these like places in between the stages. Okay, so let me put something together that should do some good damage. You can rearrange all these spells when you're in the special zone here. So I'm gonna switch some things up. This looks pretty good. This is like a little punching bag dummy thing you can shoot to see how much damage you're doing. It's pretty nice. Slap one of these on here. Now there's a way to get these spells to loop and shoot a lot faster. Yeah, I'm just trying to get all my spells lined up here. Okay. I'm just getting everything lined up because once you start getting into the battle there, it's you can't change anything. This is looking pretty good. A little bugger sneaked in here. Okay, I'm ready to do some stuff. So here goes. I'll throw one more spell in here. There we go. Alright, I think I'm gonna do pretty good damage with this. So here goes. Is there any new hyped up 3D printers that you want to see? Got a couple on the books. That thing doesn't want to die. Uh-oh. Not doing enough damage here. Oh, there you go. Down. Ender 3 V3 SE motherboard. You know, I should probably start working on that. I had a prototype put together, but you know how that goes. There's like a bunch of other projects that I want to work on, and it kind of got pushed to the side. Well, why don't we look at some other games here? Are there any games you recognize on this list of games? Yeah, the Ender 3 V3 SE is one of those things where it could definitely use some improvement in terms of the I/O. And it's just ripe for the picking there, I think. This is a fun game. Autodesk Fusion 360. Kerbal Space Program. I guess that is a little more on brand for random 3D printer maker stuff. Anyone else want to see Kerbal Space Program? What's the Soval SV08? Oh, I've got one of those actually, Brandon. You know, I might do something with the Soval SV08. But the thing is that I'm kind of jaded with all the new 3D printers that are coming out. Really, I've been putting the most time into building my own 3D printer that solves all of the problems that face modern additive manufacturing. So that's going to be pretty hype, I think. The Soval SV08 does seem like a pretty good machine, if you ask me. So, like on paper, it seems like it's going to be awesome. I haven't opened the box yet, though. Alright, Kerbal Space Program. I think we gotta go with that. Kerbal Space Program! I've also played quite a bit of Rust. This game is pretty brutal. It teaches you to never trust anyone. How's Kerbal Space Program 2, Herzelnerk? I know you've said you've played that a little bit, but from everything I've heard, it's not quite ready, or it's kind of buggy or something. Wow, this is a bright flash screen here. Splash screen, we'll call it. Yeah, so Soval SV08, it's definitely going to be a good competitor to put up against Bamboo Lab printers. I think it's like what I would have designed if I was going to make a Bamboo Lab killer type of machine, which might be the title of my video, should I make one. Build a house in Rust and it'll get blown up in no time? Yeah. Yeah. Well, I don't usually get raided because I'll build my base to be so chunky that nobody wants to take it out. And I do all sorts of bastardly tactics. Okay, so Kerbal Space Program. Let's just start a new game. What difficulty should I do this on? Anyone familiar with the difficulty settings in Kerbal Space Program? I really like this other game. Risk of Rain 2 is pretty fun. Diablo 2 is a classic. This Dome Keeper game I played for a couple hours last week, or a couple days really. It's pretty fun, but I kind of ran out of stuff to do in it. But it's a fun game. Rift Wizard is another kind of... I don't know how many people actually play it, but I kind of like it. Sandbox is fun? No, we can do better than that. We need this game to be difficult. It's been pretty bad, but now it's playable. Most of the game-breaking bugs are fixed. Alright, that's good to hear. Counter-Strike. Classic game. And RimWorld, this one's really fun too. Yeah, that's true. I'll load up one of my previous games. If you want to mess around with like a huge budget, I think I've got a... let's see. My most advanced one with the most money here is MKGA. I'm not sure what the difficulty is there. I think it was probably like a medium difficulty. Career will be challenging if you don't have much... Oh, well, you can see my experience level right here, Herzelnerk. I'll just open some of my existing designs. This is my latest ship on this. I think it sorts by... oh no, it's an ABC order. So... here's just a couple of my rockets. Yeah. What else we got? This one I can't even afford to build, but here we go. I haven't done anything on for the planes. I haven't built any planes on this game. It just seems kind of difficult to get going with that. This one was supposed to be able to land on the Venus planet. Looks like it's not finished, or maybe one of the patches broke it. That's probably what happened. Sometimes the patches will make things a little weird. Like maybe they shortened this motor module and it broke the connection there. But you can see I start these with an angle. I actually tipped this a little bit. You can see it's not perfectly straight. So that way it's got the initial launch trajectory built into it. That's something that I like to do. Let's see. What else we got? I know there's a couple here that were like like I'm pretty sure I've been to like all the planets. Lots of fun stuff is what this one's called. Let's see about that. Yeah. Triple Moon Orbiter. Okay. Planes aren't too bad if you consider cog and call. What's cog and call? Center of gravity and center of lift? Okay. Well, I could do that. I might be qualified to try something like that. Let's see. Let's pick a mission. Okay, attach a new part. Active missions. Okay. Ultimate Eve 6 voyage. Fly by Eve, Lethe, Moon, Minmus, Jewel, and set your vessel on a crash course for Kerbal. That seems pretty complicated. Yeah, both of these seem really complicated. Fly by Lethe, Duna, Minmus, Tylo, Jewel. Let's see. Oh, cool. What's going on over here? I've got a bunch of ships orbiting around right now. Oh yeah, this one I had barely insufficient fuel to complete the mission. So yeah, we're out of gas. We almost made it, but not quite. Poor little Kerman over here, stuck out in space. This one seems nice and approachable. Let's just do the Lethe 3 course. So Eve, Lethe, and Jewel. Alright, where are those located? So Eve, Lethe, and Jewel. Here's Jewel. There's Lethe. Lethe and Jewel are right there. Where's Eve? That's not it. Oh, oh no. That's the... Yeah, that's it, this one. Alright, so I've got to fly past Eve. I think I can do this mission. So we'll give that a try. Eve, Lathy, and Jewel. Don't have to orbit any of them. I think I can do it. Eve, Lathy, and Jewel. Huh. I might be able to tackle this mission at the same time. So we'll try and do a double whammy here. Hey Nadiv, we're just playing some games here. Fun 45 minutes of maneuver planning. You can solve these problems faster with enough delta V. Alright, this one's called 10K Delta V. Maybe this will be enough to get everything in orbit as needed. So let's put an experienced pilot on board. Oh no. Where are all my pilots? I think I may have had an accident with them. Let's see. Okay. Jebediah is on vessel Ken. Okay. Let's try and get Jebediah back. He's going to be very important for this. Okay. He's already on a mission here, it looks like. Where's he going? Oh crap. Oh no, I just pressed spacebar twice. That's not what I wanted. Uh-oh. I'm just gonna leave and hope that fixes everything. I don't think I can do Kerbal Space Program. It's a little too much for me right now. Some of these games, it's like... it's as complicated as doing actual engineering work. I just want something simple. So I'll do one round of Rift Wizard so you can see what this game's about. And then I'll do RimWorld, which is a fun game. Okay, so here goes. Alright, here's another game where you're a wizard. Seems to be a theme. So this one, you cast spells as a wizard. And I'm gonna mess this up. I just know it. Alright. Dave the Diver is my game right now. I'll look up Dave the Diver. Let me check it out on my other computer. Game published by Mint Rocket. You explore deep sea environments to gather ingredients for a sushi restaurant. I mean, those are some pretty high reviews it's got there. It looks kind of fun. Overwhelmingly positive reviews. That looks pretty fun. Not gonna lie. I'm just gonna try and speed run a couple of rounds of this game, and when I die, we'll call it quits. This game it's turn-based, so if you kind of go fast, you end up making a lot of mistakes. So I'm just gonna go fast and see what happens. How to do fire, holy nature. Yeah, the graphics on this game are awesome. I know what you're thinking. Amazing graphics. It's kind of like those old text-based games where I guess it's ASCII. Dave the Diver. Alright. It's a fun game. You don't need to spend 10 hours of play in it. Alright, I'm gonna get Dave the Diver downloading on the other screen here. How much is Dave the Diver? $20.
Meet Dave, an interesting little human with a precarious love for the sea. He spends his days diving the chilling depths of a mysterious blue hole. And when he isn't merely surviving or rummaging resources, he's often found snapping photographs, racing seahorses, farming, and really anything that grabs his attention. It's this gluttonous appetite for adventure that...
All right. We'll slap Dave the Diver into the cart. Okay, we got Dave the Diver downloading. I'll try that out next time I'm looking for a new game. There we go. I think the next stream I do will be putting my custom 3D printer together, because that's something I've been putting a lot of time into. Massive frame. I think I kind of have been teasing that a little bit, but it's going to be a lot of fun. And that's all done. Okay. Is this game comprehensible to anyone, or is it just utter nonsense on the screen? Uh-oh. Oh no. This isn't looking good for me at this point. No. Okay. Let's start a game of RimWorld, and we'll make this interesting. So, RimWorld is another game that I really enjoy. All these two-dimensional games. So, we'll start up Dave the Diver too in the side. Ooh, Dave the Diver loaded up faster. So we're gonna go with it. Alright, do you have any, Nadev, if you're still here, do you have any pro tips? Oh yeah, you've played RimWorld? I like it, it's pretty fun. Yeah. Alright, we're on the beach. Alright, he wants some sushi. He's got his go bag ready to go. Oh yeah, Factorio? Yeah. I haven't played Factorio. It seems like it has too much depth. And once you get involved with it. I mean, you might as well be routing a PCB. I might as well be designing the next motherboard instead of playing Factorio. Ender 3S1, Sonic Pad or Arduino or Merlin? You mean Marlin? The firmware? Those are 3 different things. Alright, we're gonna skip this this flight. If it'll just drinking some root beer. So Ender 3S1, Sonic Pad, or Arduino or Merlin. I'd probably go Sonic Pad if those were the options. What kind of business? Okay, so we're gonna go dive for some sushi here. Oh man, there's another game that's awesome. Have you, let me check if it's downloaded. I'm gonna get it downloading on my computer here. It's called Teardown. Try moving to the marked area. With left shift you can move quickly. Alright, so it's like sprinting. Let's practice using the weapon you'll need, the dive knife. Try using the survival knife on a small fish. Good job. Okay. Do you have to, like, deal with nitrogen saturation and stuff? Oh, I didn't think I stabbed one, but... Alright, harpoon. Okay, aim with right and fire with the left. Alright, we gotta look for Nemo. It's time to go find Nemo. You know, I could go for some sushi right now. It sounds pretty good. Let's do it. Press space at the arrow to go to the sushi bar. Let's go. Oh yeah, I've watched Super Heavy Starship. Yeah, the stuff SpaceX is doing is pretty awesome. It's hard not to be a fan about that if you're excited about space travel at all. I'm Bancho. So you like sushi? How empty a life one lives without ever tasting the beauty that Mother Nature can offer. My calling is to bring the taste of Mother Nature to everyone. Alright, let's get to sushi diving. 7 more fish. Best quality ingredients. Alright, let's do it. So, Nadav, if you're still in the chat, how deep does this game go? The incident. RGV aerial photography? Oh yeah. Yeah, there's a lot of sites covering all the Elon engineering stuff. Ah, okay, so I got a certain amount of oxygen. And I can only bring a certain amount of fish back up, so... Oop. That thing looks delicious. Oh, what? Mash spacebar. Okay. That fish looks a little bit hard to, Okay, I have a baseball bat now. Alright, I really want to get this one. Uh-oh, critical depth. Don't want to go past that. Oh. I don't know what I'm supposed to be doing there. Do I have to shoot it like 5 times to wear it down? Spacebar! Okay, there we go. Alright, I'm gonna go for some easier fish. I'm gonna try out that escape pod. At this rate, we'll make boatloads of money in no time. Oh man, now I have to cook the fish. Okay. Okay. C to close the ingredients window. Alright. New recipes need to be added to the menu before they can be sold to customers. There's a sushi recipe for the fish you acquired earlier, so try registering that to the menu. Okay. Setting ingredients to auto-supply will make things a bit more convenient. Only food on the menu can be sold, so if you run out of ingredients, you have to replace items on the menu or refill the ingredients. I'll just add all the stuff that I have here. Okay. Pour the right amount. Wow. Alright. Ah! Okay. Spilled some. Alright. Run. Oh man, I could eat that. Don't forget to press E after filling the menu business to begin. Okay. Ah, there we go. Nice. Oh. Oh crap. Okay. There we go. Huh. Not bad. Well, bam. I think I gotta go get that octopus at some point. Are you the man who's been diving around here? Biology at the local graduate school. I've come to investigate after reports of anomalies. Oh yeah, that's probably what's causing the earthquakes, that giant thingy there. Okay. Alright, we'll do one more dive and probably call it. Thanks for the game recommendation, Nadav. Alright, let's get some agar and some starfish. Oops. Uh-oh. I'm gonna die. This pufferfish is tricky. Maybe I should have went up for air earlier. Rift Wizard 2 came out in early access. Cool. I'll have to check that out. Yeah, I beat all the challenges on Rift Wizard 1. I'm gonna check out Rift Wizard 2. Oh, nice. Wow. That looks much more Rift Wizard-y. With higher resolution. Wait. I think that's a little bit bigger than the previous game. It looks like it has a lot of the same stuff as the previous game. Like at some point they were like, you know what? I should just make this a new game so I make more money. It's got items instead of shrines. Okay. And also your spells and health recharge every floor. Interesting. I mean, that looks fun. Wow, and they've got multi-square enemies now. Like, this guy takes up 9 squares. Alright, I'm down for that. I'm gonna buy that. Alright, thanks for the tip, L. Okay. Oh, a gun. I thought divers were athletic and muscular. Oh. Alright, I'm gonna make this gun. Wait. Do I go somewhere? Oops. Hit space one too many times. Okay, find rope, find scrap iron. This looks like a thing. Starfish. Collect wood. Okay. Oh jeez. Oh man. Okay. This game seems pretty fun. I'm gonna get that thing later. Ooh, shock bang stick. Alright. There's our rope. I gotta find some scrap metal now. Let's oxygenate there. Okay, there's a moray eel. It looks like it'll mess me up. Pacha. get Nemo. There we go. Bad fishy. Huh. Okay, R. Left shift for boost. Nice. Oh, geez. Lionfish. Get out of here. Alright, how's my quests looking here? I'll get one of the... Ooh, jeez. I'll get this guy and then... maybe this thing down here. Get some copper ore. Call it good. Nope, can't. Fusion 360? Star Guy, you're coming in with the donation. I feel like I have to do a little Fusion 360 now. I wonder if there's a way for me to do that on another computer. Because I actually have been using Onshape a lot lately. Alright. I got a basic underwater rifle now. So Star Guy, what are you thinking in terms of a CAD tutorial? I can do a quick CAD tutorial. I mean, so we'll just design a little 3D printer real quick. What do you think about that? Alright. How do I quit the game? Dave the Diver seems like a fun game. I'll have to try it out off stream. So, let's see. In terms of CAD, let me get Onshape going. I'll create an account real quick here. I don't know if you've used Onshape before, but that's the one that I would kind of recommend for people getting started now. But I'm going to start a little account here without anything on it. So, oh, 3D modeling software. Okay. All right, Star Guy. Let's design something. What do you want to design? I can share the STLs or whatever files with you guys as well. All right, so I'm just, go to onshape.com if you want to get started. And I'm going to make a new account with a different email address so that you can't see all of my models that I'm working on. But I do have a I do have an Onshape account, like a professional account that I do other stuff on. But I figure I should just make a new one so that it's not displaying all my models I'm developing right now. Lawnmower wheel. Okay, sounds like you have something in mind for this project. Homemade gamma knife. What's a gamma knife? I'll look up gamma knife. Oh. Something for this? I mean, that seems pretty intense. I'm not sure if we can get that accredited or like approved by the FDA. Radiosurgery, radiation therapy, it's probably some kind of cancer treatment. That's crazy. Yeah, I've always thought that's pretty interesting stuff. Okay, so default unit, we're going to go with millimeter. Linear acceleration unit, meters per second squared. Angles in degrees. Angular velocity degrees per second. We'll just do the Onshape default controls. Profile, there we go. Okay, so let's create a model. We'll call this Toro wheel. Alright, so you want to make a wheel for a Toro. If I was going to make something like this, okay, so the axle, let me get this straight. For the axle, it's just going to be like a solid peg, and then you'll want to put a wheel into the bearing, and then mount that onto the axle, if I'm understanding correctly. So you'll probably want to use a bearing like this. Also, if you aren't familiar with McMaster, you should definitely get familiar with them. But this is like the standard 1/2" diameter wheel bearing. So, yeah, we can just take those dimensions. But you said a 200 millimeter in diameter wheel with a 1/2" hole for axle shaft. Does it need to be an idler wheel so it has a bearing built into it? Oh yeah. Okay, thanks, Star Guy. Very generous. Yeah, this will just get uploaded. Oh, so it needs the bearing inside of it. Okay. So first things first, Star Guy. If you gotta log off, you're just gonna have to pick up from here without any guidance. But so we'll click Sketch, and we'll look at this from the top. I'll probably model this so that you're looking at the wheel from the side, because usually that's the orientation that wheels are in. And we're going to do a bunch of circles here. Inside circle will be our 1/2" diameter. Our outside will be the 200 millimeter diameter. And then our intermediate dimension there will be determined by this wheel, this type of bearing. So this is a standard 1/2" inside diameter bearing. So it's for the housing ID of 1 1/8 inch. So we'll just go ahead and copy that. So this will be 1. We have to put this in parentheses and type inch. And that'll be 1 plus 1/8 inch. And that'll give us the dimension in millimeters there. So you got that. And then the wheel has, this bearing has a 5/16 inch diameter. So let's just extrude this. So the shortcut for extruding is Shift E in this software, and then we can extrude our wheel there. But let's go back into the sketch. I'll show you how to do it without using shortcuts so you can see what I'm clicking on. Makes it a little easier to follow. So we'll hit the check mark to exit the sketch. That like finalizes it. And actually we'll go back in here. You can double click to open the sketch back up. We'll name this wheel sketch. And then you can start extruding things out. So I'll click this inside diameter here, and we'll do a, we'll model this wheel so that it's symmetric. So I'll do a, we'll make this wheel, let's say, 2 inches or 50 millimeters thick. So this will be the whole wheel. And then, well, actually, any feature here you can just double click and modify it. So I'm just gonna extrude the wheel like that, and then extrude again. I have to unhide the sketch because it hides the sketch after you're done with it by default. So you can see here, I can toggle the visibility. So now we can see that sketch again. Otherwise, when I try to extrude something, I can't click on any of the sketch features anymore. So we'll show the sketch, and you can actually hide the wheel and hide the planes. Quick shortcut to hide and show all planes is P, so if you hit P, it makes them all appear or disappear. I like just making the thing disappear. So now we can see our sketch and our wheel, and I'll just extrude this inside portion symmetrically, and the diameter we'll select would be 50 millimeters minus 5/16. So 50 will bring that inside part out to the same width as the rest of the wheel. Then we'll subtract 5/16 of an inch times 2. And what that'll do is it'll give me a cavity on both sides. That's the right dimension to have that a bearing sitting in on each side. Now I'll use thicken. This thicken feature is pretty handy. It's this one right here. And I can use that to subtract out some material. So I'll add in like 5 millimeters of clearance. So right now that central hole is 1/2 inch, but if you're, installing that onto a 1/2 inch diameter rod, then you're going to have it kind of interfering there. So you want to add some wide clearance, and then I'll model in some bearings here. Well, actually, I'll do another thicken feature here on both of these bearing surfaces, and I will reverse the direction and make it like 0.5 millimeters. So that's just going to make that hole a little bit larger so that when you push the bearings into position, they'll fit. Otherwise, if you design everything to be the exact dimension, then when you try to push the bearings in, it's not going to work. So we just extrude a little material there, or remove a little bit of material so that your bearings will fit in. Now let's model the bearings. We still have our wheel sketch visible, and we have our bearings. So I'll have a starting offset for this, and I'll click this inner shelf here, and then we'll have this bearing be 5/8 of an inch. Did I get that right? 5/16 of an inch. And we've got a couple options up here. One is to make a new part, one is to add a part, one is to remove, and one is to intersect. Basically, right here, if we add this part, then it'll combine these into a single piece. You can see they're the same color. So this is all like one entity here. So if I hide it, you can see everything is all on one part. But we don't want that, so let's change this to new. So that's going to create this bearing as a new component. So now we can see our bearing. So cool stuff there. So let's start naming these. We can rename this to wheel, and then we can rename this to, this bearing is a R8. It's not letting me copy paste that, but R8-2RS. So we'll rename this to R8-2RS bearing. So yeah, it's nice to just name your entities so that you know what's going on here. And I want to have one of these bearings on each side. So I can go ahead and mirror this. So first thing it wants us to fill out is entities to mirror, so we'll just click that bearing. I can click it in the graphical user interface here, or I can click it down here in this parts list. And then I click the mirror plane. Remember, P allows us to hide or show those planes. I want to mirror it about this right plane. So I can click it up here, or I can click the graphic entity here. And that's going to mirror it over to the other side. and I want to click New. You know, it defaults to Add because it thinks I want to combine all this geometry together, but I'll set it to New. We'll hit OK there. So now we've got our bearing on each side of the wheel. And I'll change this. I'm going to rename everything here so that it's easier to follow. I'm going to rename this to Wheel Extrude. We'll rename this to bearing bearing surface. I don't know what to call this. I'll call it a bearing flange extrude. But it's basically what the bearings are going to be pressed up into. You know, this part here. We're going from, oh, by the way, you can use this rollback bar to kind of progress through the process of building this. So first we create the sketch, then we do the wheel extrude, then the bearing flange extrude, then thicken to create some axle clearance. Then we'll do thicken 2, which you can see that just made this bearing surface a little bit larger. So we'll rename this to bearing fit clearance. And then we created the bearing, and you can see there's a little bit of space inside of there, which is what you want. Otherwise you'd have an interference fit, which would be like a press fit or something, which is kind of hard to get working properly. But yeah, this is the bearing extrude. That's like the feature that created the solid part of the bearing. And then we mirror it across to the other side. Now we need some way to retain this bearing, and the easiest way to do that inexpensively is to add some screws that just kind of get screwed in on the top, bottom, left, and right to retain that bearing. So, you know, you install the bearing, then you install a couple screws, and those will hold the bearing in place. So, anyone else in the chat, if you've got some CAD ideas, if we can keep this going, if you want to learn more about CAD. I'm a certified master of engineering, so you know, I used to do this for a living. I'd say I'm a better engineer than I am a content creator. So if you guys like me doing this kind of stuff, yeah, I'm pretty good at it, so it could be fun to do. Anyways, yeah, we want to add some screws that are going to basically hold this bearing in place. So I'm gonna go back to create another sketch on the, let's do the right plane again. We'll hide the wheel. And I want to make a series of bolt holes around the perimeter of this bearing that I can screw things in to fasten that in place. Now my favorite fastener is the M5. It's a 5mm fastener. I'm going to create a circle at the origin, and then alright, so first thing I'm going to do is create a circle at the origin. I'll just restart here. So I press C to create a circle. It's really intuitive, but you can click it up here. Create a circle, hit escape, and I'm going to change this into construction geometry. You can click this button up here or press Q. So this is just construction geometry. This helps visualize where that circle of holes is going to go. and then I'll create another circle, and you can toggle between construction geometry and non-construction geometry using Q. So I'll be doing that a lot. But yeah, you want this to be a circle there. And I'm going to hide the original wheel sketch because it's kind of distracting, because if you click it, it kind of highlights this face. I want to hide that wheel sketch here so that we're not seeing it. Alright, so and I want this to be for an M5 screw. And I want this to basically be 2 millimeters. We'll do 1. Hold on, let me think. I'll have the center of this hole be 3 millimeters. We'll do 4 millimeters. Okay. Center of this hole is 4 millimeters away. And let's draw out our fastener. So we're going to use an M5 fastener. M5 screw. Now I use socket head cap screws for everything. I can't recommend them enough, so we're going to design this to use a socket head cap screw. Hey Teaching Engineering, we're doing some CAD work. We were playing some games earlier. Just some stuff to get me off the monotony of all this paperwork I've been doing. So yeah, we'll take an M5 screw. There's a couple ways we can do this. We can use a screw with some bolts, but like the simplest way to do this is to just take a screw and thread it in right there. It might come loose over time, so there's probably a better solution if you want something that's going to be durable. So I'll go through a couple different solutions here, and we'll actually include them all on the same 3D printed model, because adding extra holes in a 3D printed model is basically free. So this first sketch, we're just going to design this for a M5 socket head cap screw, a 10 millimeter long one at that, because that's the, I don't know, that's just like the standard fastener. So we can go into the product detail here and see all these nice drawings on McMaster, even with an engineering drawing, so we can see all this good detail. So the head of the bolt is 8.5 millimeters, it says right there. So I'm going to draw that in. That's 8.5. Okay, and this shows me that I actually do need to move that a little bit closer. So we'll call that 3 millimeters there. And that should fit nicely. So the bolt itself is going to be 5 millimeters. So if you look at that from the side, basically this, if you were to kind of pinch this bolt with a pair of calipers all across those threads, you'd have about 5 millimeters of size there. So in order for the threads to engage, I need to move this down from 5 millimeters. I always subtract 10%. So originally we have 5 millimeters. We're going to subtract 10% of that. That leaves us with 4.5 millimeters. All right, and I'm going to hide this. I'm going to turn this into a construction line. So press Q to toggle, or just click it up here. All right, so we've got this, and I'm going to create a circular pattern. And the way that they do this in Onshape is a little bit weird. It creates an undefined circular pattern, and then you have to kind of drag this to move the origin of the pattern away. You can see it right there. And I'm going to drag and drop it onto the origin of the sketch. So now we have this 3-bolt pattern that we can use to secure this bearing. I'll just increase it to 4 holes. That way we have a little bit of redundancy. So if one of the bolts falls out, it's going to be okay. So now we have these holes. And I'm going to extrude, either Shift-E or click that and select all those little faces. The other way to do this is to click extrude and then click on this sketch, and that'll automatically select all the faces there. So instead of adding material or creating new bolts here, I'm going to first remove material symmetrically in a 100mm depth. So this is like, it's going to drill out all the material in those red cylinders. And we're going to show this wheel again. We'll click the wheel, and now that's going to introduce these 4 holes here. And, you know, that's your holes. And you can thread M5 screws directly into these holes, and they'll hold the bearing in place. Cool. So does that make sense? What's the closest CAD I would compare Onshape to? I would compare it to SolidWorks. It's really similar to SolidWorks, except it's always online, so you have to have an internet connection to do any of this, which, you know, in my time using it, it hasn't really been an issue because usually you're on the internet when you're doing CAD. It's really fast, like even when I have complex models open, and it's really intuitive. So in that way, it's really similar to SolidWorks. But it's a lot more limited when compared to SolidWorks when you're talking about like assemblies and all that kind of stuff. So for more complex engineering stuff, I would probably still stick with SolidWorks. But for this kind of stuff, it works great. All right, now I'm going to model those fasteners just so you have something to see there. I'm going to double click, we'll rename this sketch to M5 bolts. And I'm actually going to rework this a little bit. Yeah, so Onshape is free if you are using it for personal or hobby use. I have a professional license for Onshape for some other stuff that I'm working on. But for things like this, where I'm just going to be sharing the models with other people, I'm just doing this on basically a burner account for, you know, so that I'm not showing all my CAD models that I'm working on. But also because it automatically open sources or, you know, publicly publishes all of your designs if you're using a free version. So you'll be able to open this up and create your own version of it or modify it if you want to. Okay, so I'm going to change this design. So instead of having these M5 bolts just fastened directly into, well, I'll show you what I was planning here. Let me just model everything up. So I'm going to turn these back into construction geometry. And we'll have to double click and kind of inform. Oops. You can hide all the, okay. Hold on here. So I'm going to hide all the parts, and we're going to go back to this extrusion step. Now it's thinking that it needs to extrude the rings instead of the centers. So I had to basically just, you can delete all of the features there and just click the middles of these circles so that it drills out that material like before. And then we show, and there you go. So before I was planning on having the bolts like this. So So starting offset, oops. Right here. make a new solid that's 10 millimeters deep and it's really convenient to just hide all the parts when you want to look at your sketch. And this would be the bolt's head. If we look at our drawing, it's a 5 millimeter tall head, so we just put 5 millimeters in right here. So this is what I was kind of envisioning at first. We would have 4 of these bolts just threaded directly into the 3D printed part. But since opinion of rat rigs are nice machines if you don't mind building them yourself. But back to the CAD program. Since he said this is going to be on a lawnmower, there's a bit of a safety concern with these bolts falling out. Like, you want to be very certain that these bolts aren't going to just come loose and drop into the lawnmower blades and get kicked out. So I would want to do something a little bit more secure here. So instead of just using these bolts fastened in like this to retain the bearing, instead of doing that, I would want to do something like a full-length bolt that goes all the way through and uses a nylock washer. Basically, a nylock washer is going to be a lot safer for this application. Oh, nylock nut, I mean. So you can get a nylon locking nut, and these have a little I'll open up a little model there. Let's go to M3. You can just type in M5 nylock nut. M5 lock nut. So here's our M5 lock nut, package quantity of 100. We probably don't need that many, but we'll go with that for now. If you buy this on Amazon, you could probably get them in lower quantities or your local hardware store. But these have a little piece of deformable material in here that when you attach it onto a bolt, it kind of locks in place and it won't come loose under vibrations. I mean, it still can come loose, but it's less likely to. So I'm going to have instead of a short bolt like this, I want to have a long bolt that goes all the way through. So something probably that long. So that we have room for washers and the lock nut. So probably 60 millimeters ought to do it. And yeah. So let me redefine this sketch actually. Instead of defining it in this mid plane, I want it to be on this surface so that it's just easier to define everything else in relation to this surface. So I'm going to double click this sketch. You can see here I can either right click and edit, or I can just double click to immediately edit. Instead of using the right plane to determine where this sketch is located, I'm going to exit out of that and just click on this surface here. So now the sketch is on the surface of this part, and it's just a little bit easier to comprehend here. The downside of using surfaces to define a sketch is now the edges of the defining feature are going to appear in the sketch as entities. So what does that mean? That means this edge of the sketch is now being used to determine what should be extruded here, which is a little annoying, but you can work around it. So we just go back to this and we just select to use, instead of just this portion, we want to use both of these pieces. But let's go ahead and delete both of those features. And we want to redefine our sketch here. So I want to add some more stuff to the stack up. So I'm going to add an M5 washer. So how big is an M5 washer? We consult the Oracle, that is McMaster-Carr. So general purpose washer, M5. We'll pick any of these, stainless steel, whatever. It looks like most of them are 9 or 10 millimeters. Let's just go with the 10 millimeter version. And then just make sure when you're buying your washers they're 10 millimeters. So this is 10 millimeters. Then this is the bolt head, which is 8.5 millimeters. And then I'll change this to be 5 millimeters as well. So yeah, I want to size this whole pattern so that the washer overlaps with the bearing. So if I had it like this, the washer would just barely be up against the edge and not actually retaining anything. I'm going to make it a little bit smaller so that now these washers are overlapping right here. They're going to hold that bearing in place. And I can actually design this for a 9 millimeter washer, and that way if you get a 9 or a 10 millimeter washer, it'll probably work. Okay, so that looks like about the right amount of overlap. That'll be nice and safe. And I'm going to make this a clearance hole for an M5 bolt. So usually you upsize it about 10%. So this will be 5.5 millimeters. And that should get the job done. So now we're going to use this sketch that we've defined to kind of create a bolt stack up. So I'm just going to delete those other instances. Instead of creating a bunch of instances of that in the sketch, I'm going to create one bolt stack up and then create a pattern of those around the outside. The one that I probably... Okay, let's do some fine tuning here. So you can see this, the space around this bearing is pretty generous. We probably can reduce that clearance a little bit. So I'm going to go into my bearing fit clearance feature, and we'll turn that down to 0.2 millimeters. Now that clearance isn't quite so large, which is kind of nice. So now we'll do another extrude. We'll delete out all these features, and we'll basically just click this one, and we're going to increase this to, let's say, you can just make it like 1,000 so it cuts through the whole part. See, this is the what's going to be cutting through this thing, because I have the symmetric thing clicked. Instead of just going out one end, it'll go out both sides, which is just more reliable at cutting through things. And then merge scope, I'm going to click this wheel. You select that, click the wheel, and then that cuts you a little hole here. But immediately you'll notice there's something a little bit fishy about this geometry. You can see it's coming really close to this edge here. So your 3D printer isn't going to be able to actually print that part. And I like to just design things... Well, actually, your slicer will load this up and it'll probably just kind of round that off there, which isn't a huge deal. But I can also just increase this diameter a little bit. So we'll increase that to 36. I'll move that away from the edge. And we should still have enough overlap so our washer is retaining that bearing. Okay, so that looks good to me. I'm going to go ahead and add one more circle to this sketch, which will represent the major diameter of the M5 bolt, which is 5 millimeters. And we'll make sure that it's cutting out the right size hole. In this case, I want to cut out that 5.5 millimeter diameter hole so that there's clearance for that 5 millimeter bolt. Alright, so next step, I'm going to extrude this bolt. Whoa, hold on. First up, I'm going to extrude the washer. So I basically want to pick all of these sketch entities. And if we look at our general purpose washer, it's 1 millimeter thick, nominally. So that's what we'll use for our CAD model, 1 millimeter. And that's going to be a new entity. And so we've got our washer there on this side. I want the washer to be on both sides. So I'm going to take this mirror feature and move this to the end and double click it. Now I can select that washer. Now we've got the washer on both sides. You can see before it doesn't have the washer. We'll click the washer. Now it's on both sides. Okay, and I'll name this too. So rename to M5 washer. Cool. And then we'll do another extrude. We'll hide that washer. I'm gonna click all of these features. And this will be the bolt head. So bolt head is 5 millimeters thick, 8.5 millimeters in diameter. So we'll have that be 5 millimeters out, but I'm also going to create a starting offset. I'll unhide that washer, and we'll start the offset from the washer. And we'll create a new entity. So now we have the bolt head, we have the washer. On the other side, you have the same washer. And then we'll create the shaft of the M5 fastener. So let's hide that wheel, hide that washer, just so that we can see everything we need to see here. We'll do another extrude. I'll click this inside piece, which is this is basically our 5 millimeter nominal dimension for that bolt. So we'll do a starting offset entity. We want the bolt to start at this we want it to start at the washer. And then that'll go through to this other side, however long we want our bolt to be. We can see what different bolt lengths look like. This is a 60 millimeter bolt. We could do a 55 millimeter bolt, and it's just sticking out a little. We could do a 50 millimeter bolt. You can also just type it in up here and it'll show you. But you can see a 50 millimeter bolt won't be long enough to fasten onto a washer on the other side. So I'm just going to go all the way up to the 60. 55 millimeter bolts are less common anyways, so just round up to the nearest 10 and that'll be good. So there you go. And I just hit OK, but really what I want to do, instead of doing a new, I'm going to add this to the bolt head. So now this whole bolt is a single entity, and I'll rename this M5 by 60 bolt. All right. Then the last thing I want to do is put put our lock. What did I call it? Our lock nut on the other side here. So I'm just going to sketch that up. So again, I just click on this other side. We want to have our little lock washer, one that looks just like this. So we'll click sketch, click on that washer, or this washer here. We'll create our inside diameter, which is going to be 5 millimeters. And then we'll create an inscribed polygon. So if we look at our nut here, it's 8 millimeters across these two faces. Is everybody excited by this CAD modeling stuff we're doing? What's your opinion on VZ bots? VZ bots are nice. I've seen one in person. I mean, it really depends on whether you want to build one or not. The best printers out there. Okay, well, there you go. Anyway, so we want to make an inscribed polygon, so we click this little button up here. And click the center, and then it automatically will create a hexagon for us. So we'll just click that. If moving the mouse left to right, it creates or decreases the number of facets on this polygon. We want 6. 6 is kind of the default. So there you go. I press escape to get out of that mode. I press D a lot to create dimensions. That's something I might have been doing this whole time because it's intuitive. But yeah, you can press D and then or click up here to create a dimension. And then we want the distance between these two to be, was it 8 or 9? I think it was 8. Yeah, 8 millimeters. And there's no rotational position of this nut defined. So it's just kind of floating around like this, which is kind of confusing. So I'm going to click one of these faces and set it to be horizontal. So I can click this button here or press H, and that's just going to pick one of these to be horizontal. I think it's this one right here. Yeah, I picked this line to be horizontal, and that helps define that nut so that it's not just like spinning around. You can leave it spinning around, but it's a good practice to fully define all your parts. So then I will extrude this nut again. I just pressed Shift E to extrude that, but I'm gonna delete that. I'm gonna delete this to show you how to do it a little bit more slowly. So click that, and according to our sketch, this nut is 5 millimeters thick. There you go. And if you want, you can model this little bulge at the top here if you really wanted to, but I just went with the 5 millimeter dimension that includes that bulge. So I'm not going to model that just because it's a kind of a frivolous detail of the design. Ever seen CAD versus CAD? Is that like a competitive CAD esport event? That sounds fun. So there you go. Now we have a washer that holds this this bearing into place. So both of these bearings are going to be held in place by this little washer up here, but that's not going to be enough to hold on to the whole thing. So we're actually going to do a rotary pattern. So a circular pattern, and we're going to click all the things that are in this bolt stack up. So the bolt, the washer, And on this side, this washer and the nut. And the axis of the pattern will be the same as the axle or the wheel diameter. So I can just click on the outside of the wheel, and that defines this central axis that those will be rotated about. And we'll hit OK. So there we go. Now we've got our bolts that are going to hold this whole thing in place. So you might have noticed I missed something here. I'm going to do a section view. I don't do section views often in this software, so I got to figure out where it is. The nice thing is you can click up here and search the tools. I'll just type section or cut view. I want to do like a cut through the middle of this thing so you can see what's going on. Oh, here we go, section view. So it's in, it's up here next to the box. Camera and render options. Oh, is my head covering that up? Oh no, hold on, let me move I'll move down here. Yeah, so we've got our view triangle, our view cube up here that I've been using. This helps you pick different views. Rotate your object, and that updates as you move the part around. So I was using that to manipulate the views. If that wasn't making sense, then my bad. But you know now. So you're going to want to do a section view. I'm going to click the front plane to do a section view and cut. And now we can see some interesting stuff here. So I'm going to hide all the sketches. And what do we see here? We can see up here, this looks good. We've got a little bit of clearance around that bolt, so that's all good. But down here, it's highlighted it in red because there's interference between these two parts, between our wheel and one of these rotated bolts that we have. And the reason is, if we hide all those bolts, hide, oops, shit, I mean crap. Hide. So you can select everything you want to hide here, then right click and do hide. I'll hide all of them. You can see I didn't revolve this whole pattern, I just revolved the parts. So I'm going to show you a method that I use pretty often. It's kind of an advanced method. We're going to disable the section view. But I use it all the time, and it's something that I feel like you should learn how to do. So I'm going to do circular pattern. We're going to pattern the wheel. The axis of the pattern will be the wheel. So you can see it's created 4 instances. We can, do 10 if we wanted to, but I'll just stick to 4. And I'm going to intersect and merge that with the wheel itself. We hit OK. Ah, it didn't work. Well, okay. I'm going to pattern the wheel. Let me restart. So I'm going to pattern this wheel, and hold on. I just want to get everything so that it makes sense here. So I'm gonna hide everything except for the wheel. And if you want to hide everything except for the wheel, you can also just right-click the wheel and click Hide Other Parts, so that just kind of isolates this solid. So I'm going to, I'll delete that circular pattern because it wasn't what I wanted. I'm going to click Circular Pattern, Entities to Pattern, we'll click the wheel, Axis of the pattern, we'll click the outer face of the wheel, so that it picks this axis in the middle. And we're going to create New. So now we have all of these wheels all of these copies of the wheel that are overlapping each other. Then I'm going to select all of them, or I can just highlight them here. Pick all those wheels, and then we'll do a Boolean operation and do intersect. Click OK. And now that's created a pattern from that wheel, and it basically copied that hole around. And that's the best way to like design one section of the wheel and then, you know, basically mirror all the features around. That's just a trick that I use pretty often, so now you know. Hey Nathan, love the Perfect First Layer podcast. Keep up the good work. All right, thanks, Bama Brian. Yeah, the podcast is something that I do more regularly than my videos at sometimes. It's something that I recommend everyone check out. There's a link to it in the description. Solid Edge. I haven't used Solid Edge before. I've used CATIA and 3D Experience, which is like what CATIA is getting wrapped up into. There's so much advanced stuff that's happening now with 3D Experience, which I'd really like to mess around with, but a license for that is probably like $40,000 a seat, and I can't exactly afford that right now. Maybe they can give me a freebie if I ask nicely. But anyways, let me, if you want to show all the parts, you can click this button here to hide all parts down here in the bottom left, and then click it again and it'll unhide all the parts. So now we can see our whole assembly. We've got our washers that are retaining this bearing, and we got our lock nuts on the other side that are going to hold everything together. And that's all you really need. Now, this is a wheel that's going to be on a lawnmower, so you probably want to add some cross hatching on the outside surface here, or some kind of basic pattern on the outside to help it get some grip. So what I'm going to do there is we'll sketch on the front. Well, actually, yeah, we'll create a sketch on this front side here. And I'll just draw a circle right here. We'll set the diameter to something, it doesn't have to be anything particular. We'll just say 3. And I'm going to create a pattern out of that circle. We'll click OK, and for some reason it does this where it creates this pattern without fixing the center of the rotation of the pattern to the origin, which is kind of normal, or at least it makes you define that as you're going. But anyways, we'll create that pattern. We'll turn up the number of circles to, let's just say 120. Now it's created a bunch of circles all around. Click OK. And we'll do extrude. We'll click that sketch. And now you can see it's creating a bunch of circles. And instead of, we can set the distance of those circles and merge it with the part. Like I could just set this to 50 and it would go to the other side because I know that this wheel is 50 millimeters thick. And I merge that with the part, and now we've got some basic tread on here. Instead of doing that, because now when I do, if I were to change the width of this wheel to, let's say, 30, now, I mean, the bolts will need to be changed in terms of how wide they are, and all the other dimensions of this will probably need to be reworked a little bit to get that to work if you want to change the size. I could have designed this model so that everything updated automatically, which is generally a good thing to do when you're doing CAD modeling, but you know, one way to make this model a little less sensitive to changes in the earlier dimensions is to base all of your features off of the actual geometry. Some people don't like doing this because it creates a lot of interdependence between the features, which can kind of get complicated sometimes. But I'm going to do up to face, then we'll click the other side of the wheel. And there, now you can see if I were to change the width of this initial feature, let's say I made it like, you know, wider or something. Now that still spans the full length of that wheel. Control Z to undo. If you're on Mac, it's Command Z. That still works on this this thing. I'd rather chamfer the bearing seat for easier installation. That's a great idea. I can throw one of those on there. And I'm actually going to change this so that instead of adding to this wheel, we're going to remove. Because that'll create a slightly sharper tooth for this whole pattern. I think that's just a little bit more pleasing to me. What else? I could create like a, you know, you could get really into this if you wanted to and really modify the heck out of everything. But I think it's pretty good at this point. Herzelnerk brought up a good point of, let me hide everything else, hide other parts. He would put a chamfer on here. So chamfer, click that, and then I'll just click, click the surfaces where the bearing gets installed. You can see it puts a pretty aggressive chamfer on there. I probably want to do maybe a 1mm chamfer. And we can do that on the bolt holes as well, but I don't think it's really necessary on the bolt holes. So we put a 1mm chamfer on there, and that'll just make the bearings a little bit easier to install. So yeah, that's our wheel. If we wanted to, we could remove a little bit of material on these from this area, like put some holes in it. Like, it's really whatever you want to do. I can go back into this sketch that I used to cut out the tread pattern here and add a couple circles. So I can create that circular pattern, and turn it up to 8. Press enter. I'll turn that size down to 30. Then, due to the weird thing that Onshape does with these hole patterns. Oh yeah, something in Onshape, which is a quick tip. Sometimes whenever you click, it starts selecting things. So like if I'm just clicking around, it's almost as if I'm holding down Shift in other CAD programs, where it just keeps selecting things, and you can end up where you've got like a ton of entities selected, and then if I accidentally press delete or something, it just deletes a bunch of stuff. So I'm gonna hit Control Z to undo that delete. And what ends up happening if you have a bunch of random things selected, like let's say I have all this stuff selected accidentally, to unselect everything, just click out off into blank space, and that'll unselect. Or press escape. Escape doesn't work actually. Or click on a different entity type. So if I click on this, since it's a dimension instead of a sketch entity, it'll unselect all the. Oh. Yeah, it'll unselect the other stuff. So, I mean, that's just one of the core skills that you'll need to learn if you use Onshape. But yeah, I'll click this point, click that point, and set them to be coincident with each other. But you can click up here or press I. You can see the little tooltip says you can press I. So there you go, and now that's gonna cut through everything just like I did with the whole pattern. But if you're mowing a lawn with something like this, you probably don't want these holes because those will just get compacted with mud or dirt or whatever. What I will do, just to make this thing look cooler, is I'll add a generous chamfer here. Chamfer these. We'll set it to 10 millimeters. So yeah, you could cut out some deep pockets in here. That looks pretty cool. Something like this would be completely printable as well. So I'm just going to leave this like this. And that'll be a nice little challenge for you to print this off with whatever printer you have. We'll fillet these edges as well. Your printer might have trouble with this overhang here where these two intersect. So maybe I've got to, maybe I'll dial this back a little bit. We'll do 15. Yeah, that's still going to be problematic. We can do two distances. We'll do 10. Maybe 8. And 20. 25. I mean, this is the fun part of CAD. Like, once you have your model, you can start changing all sorts of stuff on it. I'll change this fillet, so now we're just filleting these. We'll set that to 100 millimeter. Or we can turn it down to 50. You know, just fun stuff. I think 100 was fine. It handled that pretty well. So yeah, here's our little mower wheel for what's his face? Star Guy. Oh yeah, it's not a belt. Okay, so there you go. That's your that's a little wheel thing. So that's about it for that model. If you want to see how this was done, you can click this rollback bar and kind of play through the design. So see, like, step by step what was done to create it. This is a really good way to get to know how someone else built a model. So you can see, like, each individual step that they made and how that changed the design. And all the way to the finished part. So there you go. If you wanted to, I would probably recommend using larger washers for this. They're called fender washers usually, the larger sized ones. And I would actually cut both of these faces back a little bit. So you can click here, click there, then do thicken again, and subtract off like one millimeter. Oh, I must have added a millimeter. I want to subtract a millimeter. You can see the effect that has when you flip it around. Yeah. Well, we won't mess with that. Just delete that out. Like, you can just go in and change things around in here as you need. Cool. So that's about it. I mean, we've been streaming for 2.5 hours here. I think it's probably time to call it quits. Thanks to Star Guy for the donations and the recommendation to check out some CAD stuff, because I think that's probably a little more on brand for the channel, and it's something I can do for you guys. If you want any models done on Livestream, just let me know. Why use 4 bolts instead of 3 bolts? The main reason is redundancy. Like, you could probably get away with just using 2 bolts, actually. I wouldn't want to try 1. That's cutting it a little too close, but even with 2 bolts, it'll retain it technically. But if you add 4, then 1 can come loose and fall out, and you're not even having to worry about anything that much. I'm gonna delete out these. I'm gonna delete out these holes, just because these extra holes that I added, just because they're kind of frivolous. They make the model a lot more complicated for no reason. And I don't want to confuse Star Guy when he opens this up later. I'll delete out these extra chamfers we did. So there you go. There's your lawnmower wheel. I would just leave it solid because there's nothing wrong with that. Unless you want it to look cool, then do something. Do something fun. Cool. Anyone have any CAD related questions before we log off? Going once, going twice. All right. Well, we're going to call it. This wasn't 3D printing, so sorry. Oh, wait, hold on. Let me share this document. So, link sharing. Turn on link sharing. Copy to clipboard. And I'll paste this in the chat and in the video description. I'm on 2 different computers right now, so I can't copy and paste this around as easily as I'd like to. But yeah, I'll paste this. Or you can just look up Toro wheel and Onshape. So that's the cool thing about Onshape, is you can look at, anyone can go into the public repository, look up Toro wheel, and you can find my model here. Like, this is public, so anyone can open this up and check it out. But I'm also going to share a link, so just share this document. Copy to clipboard. And then I guess I have to paste that somewhere. I just emailed it to myself so I can paste it into the chat here. Copy link address. Boom. And then we'll add it to Yep, there you go. That's added to the video description. I changed the video title to Video Gaming and Onshape Livestream so that people can find this later. So, yep. That's about all we have today. I've got some great 3D printer content coming up. I just wanted to take a little break from it because it was... I was getting a little burnt out dealing with these manufacturers. You know how 3D printer manufacturers are. Anyone who's bought a 3D printer should know what I'm talking about. Alright, that's all for the stream. I'm gonna close it here, so I'll stick around in the chat for a couple minutes afterwards just to answer any last questions. But thanks for joining, everyone. See you in the next video.